with on how hypothesis testing is conducted. Okay, I just give you the idea of confidence interval. Okay, you can refer to page 157 to 160. The details about confidence interval. Here I just highlight the important part of section 5.5. So far we have discussed hypothesis testing using critical value and also probability value. Now it is confidence interval. Okay, what is meant by interval here? It is referring to a range. So range will tell us there would be two values. One is the upper value or limit. Okay, second is the lower limit. Okay, lower limit, lower bound. So this confidence interval, contains the value of true beta with a certain percentage of the time. Let's say can be 90%, 95% or 99%. Okay, for example here, 95% confidence interval for beta. So what is meant by 95% confidence interval here? If you are given level of significance alpha percent, confidence interval, confidence level is 1 minus alpha percent. In this case, if it is 5%, so confidence level is 95%. Okay, 95%. Remember that this confidence level is actually type 2 error. Okay, alpha is type 1 error. The example here, if you are given that 0.5 less than the true coefficient 0.7 with 95% confidence interval. Okay, what is meant by 95% confidence interval? Let's say we have considered 100 samples. Here we collect the sample. First sample, second, third, fourth, sample 5, sample 6, sample 7, sample 8 up to 100. And the value of beta, the true value. Okay, 95% confidence interval that beta will lie between, the true beta will lie between 0.5 and 0.7. It means that there are 95 out of 100 cases where the value of the true beta will lie between 0.5 and 0.7. So it can be 0.51, 0.69991, 0.6, 0.53, 0.601, and so on. As long as the values will lie between these two limits, is 0.96997. Okay, what would happen to sample 96 up to 100? The value here outside the confidence interval. Zero 0.8, 0.9, 0.71. So these 5 samples, the true coefficient will lie outside confidence interval. This one, the values will lie within confidence interval. So 95% here is referring to 95 out of 100 cases that the true coefficient will lie between 0.5 and 0.7. So when we do the interpretation, interpret the confidence interval, we might say that the true coefficient of beta will lie or fall between 0.5 and 0.7, comma 95% of the time. This is very important phrase. Okay, what is meant by 95% of the time? 95 cases out of 100 cases that the true coefficient will lie between 0.5 and 0.7. This is the meaning of 95% confidence interval. It is not the measurement of your confidence level. Okay, for example, here you might say, we are confident, okay, with 95% that the true coefficient of beta will fall between 0.5 and 0.7. This is definitely an absurd idea or totally wrong. This 95% is not measuring your confidence level, how confident you are. No. Okay, 95% here is referring that 95 cases out of 100 cases that the true value will lie between, okay, this 0.5 and 0.7. That's why we need, okay, the phrase 95% of the time. Okay, many lecturers will interpret like this because they think that 95% is, okay, the confidence level of the analysts, researchers, and so on. It is totally wrong. You just read the book. Okay, any question?
No, doctor.
And this confidence interval can be utilized for two-sided t-test, not one-sided. Okay, because we have the value on the left of the distribution and the value on the right of the distribution. So we consider left and right. So we have two sides or two-sided of the distribution. Therefore, it can be applied only for two-sided t-test, not one-sided t-test. And the formula how to construct confidence interval. Okay, this formula, it has no problem, but I am not comfortable when I'm dealing with students. Okay, so I force you not to use this formula, but use the formula, okay, that you can see clearly, okay, what confidence interval looks like. So 1 minus alpha percent confidence interval, it can be written as of the true coefficient theta can be written as, so here is beta hat, it is not beta, minus the standard error of estimated beta times its critical value, so less than beta hat plus the standard error times the critical value. In between is the value of the true coefficient without hat. We have hat here, we have hat here, but not, okay, at the center of the confidence interval. So with this kind of representation, you know that this is the lower limit or bound, and here is upper limit or bound. Use this formula, not the formula that given in the book. Okay, what is your critical T? where critical key here is actually based on two-sided t-test, two-sided of the distribution. So you are given 1 minus alpha percent, meaning that alpha divided by 2, comma, the degree of freedom is n minus k minus 1. And you should know already what is n, the number of observation, k is the number of independent variable, and minus 1. Remember that these two elements are subscript. If you write like this, okay, it is wrong in terms of representing the critical key. Okay, this is the idea of confidence interval. Okay, next we'll go to how to conduct t-test, two-sided t-test using confidence interval. Okay, we apply straightforward example here. Okay, test the significance of variable I at 5% using confidence interval approach. Okay, before we start, I write back the estimated regression equation. So here dependent variable is y. Y hat is equal to 102.192.4 minus 90.74.674 n plus 0.3547 p and plus 1.2879 r. As usual, the steps. Okay, I know it is a nightmare for you last night. Okay, when you do the hypothesis testing, it is a must, compulsory, for you to produce steps, okay, with a complete, okay, instruction. Okay, I don't buy just one word, hypothesis, that's all. What are you going to do with the hypothesis? You remember that when you produce test or exam, you must treat the examiner want to learn something from you to get a good answer. So that your answer must be very clear. You have to present it very clear. So if you write the hypothesis, let's say I teach you to conduct the hypothesis. First hypothesis. You are thinking, what is the hell with the hypothesis? What are we going to do with the hypothesis? So, okay, the hypothesis you need to specify the hypothesis. Okay, for what reason? okay, to do the testing. That is why, okay, the first step here, okay, state the hypothesis to be tested. Not just only one word, hypothesis. And the worst part, you don't write anything, just H1, H0, and H1. This is the worst part. Remember that you are not diploma student, you are a degree student, you are master student. So your level, not only calculation that matters. Okay, the interpretation, the intuition, okay, everything, okay, matter when it comes to postgraduate level. So what I did to my first degree student, I teach them, okay, like this in order to prepare him or her, okay, in the higher level of education. If you don't believe in me, you just ask my ex-student, okay, my first degree student. So state the hypothesis that to be tested must be in full. Okay, by right, I shouldn't have emphasized, okay, this kind of such a statement like this, because it is understood once you embark on this program, okay, you must have a clear picture, okay, compared to those from first degree or diploma students or level. So here is we test on variable R, HO, H1. Colon, it is not equal. Two different things between colon and equal. And beta, which beta? We don't have x1, x2, subscript I. Subscript I. Two-sided t-test equals 0, not equal to 0. Done for the first step. Second, okay, choose or determine. Choose the level of significance. Okay, as mentioned, it is 5%, 0.05. Okay, next step is no longer compute. When you cannot compute confidence interval, you have to construct or set up, construct a 95%. How do we know 95%? Because alpha is 5%. Confidence interval for the true coefficient of beta I. Then you write the formula in interval form. So beta I minus the standard error beta hat I times critical T. Okay, times critical T less than the true coefficient of variable I less than beta I plus the standard error beta hat I times its critical value. So we have had. And here is the true coefficient. We construct the true coefficient. Okay, where critical T 0.05, where n is equal to 33, and k, the number of independent variables. We have 1, 2, 3, 3 independent variables, where n is 33, k is 3, and the degree of freedom n minus k minus 1, it is 29. And the critical T 0.05 divided by 2. Remember that this is the subscript 29. So you refer to the statistical table. Okay, some of you have the proper statistical table of two statistics. So two-sided 29 is 2.045. If you refer to the book at the back, okay, page 537, okay, it is given 29, okay, 2.045. Okay, now you start constructing your confidence interval. Your beta hat I is given by this value. This value 1.2879. So 1.2879 minus the standard error, zero point 5433. Zero point 5433. 5433, yeah. And multiply by the critical T, 2.045, less than the true coefficient. There is no head because we are going to find the confidence interval for the true coefficient, less than 1.2879 plus 0.5433 times 2.045. So this is 0.1769. 0.1769. Two point 3989. 2.3989. You get the same as mine?
Yes, doctor.
Okay. This is step 3. Then step 4 is the decision rule. The decision rule. So under this decision rule, how do you decide? Reject HO if the true coefficient beta that is hypothesized under null hypothesis fall outside a 1 minus alpha percent confidence interval. The confidence interval. Okay, meaning that, let's say this is your the true coefficient of beta okay, beta with the lower limit, beta with the upper limit. So let's say your HO falls outside, so reject HO. Okay, what happens if HO falls inside? Okay, 1 minus alpha percent confidence interval, do not reject HO. Okay, do not reject HO. Okay, now back to our problem. This is the value of beta I, the true beta I. Okay, there is no hat. And we have the lower limit and the upper limit. It is 0.1769 and 2.3989. And what is your HO? Null hypothesis states that the true coefficient of beta I is equal to 0. Okay, this diagram is actually like this. It is a distribution. Okay. So the true coefficient of beta for variable I is equal to 0. This is 0.1769. This is 2 point something. So the value of 0 will lie here, somewhere here. This is 0. So the value of 0 lie outside, okay, outside the confidence interval. So HO falls here. So what is your decision? Reject HO. So in this case, okay, reject null hypothesis since the true coefficient of beta I that is hypothesized under HO falls outside the 95% confidence interval. Please show your decision rule, please. Don't do it in one paragraph. Okay, do it in several separate lines. Okay, next, t-test is statistically significant at 5%. It is not 95%. At 5% level of significance. And lastly, the question here asks you whether variable I is significant or not significant. Okay, t-test is significant, meaning that variable I is significant, meaning that variable I has an influence on the dependent variable Y. Okay, done for confidence interval approach to test double-sided t-test.
Doctor,
Yeah.
uh, for division rule, the third variable I, instead of we write variable I has an influence, can we also write independent variable I has an influence?
Independent variable I has an influence. Okay, can be accepted.
Thank you, Doctor.
It can be accepted. Your version is more superior than me. Anything else? So the first step, state the hypothesis that to be tested. KHO, which one? Use the level of significance, alpha 0.05, 5%. Construct a 95% confidence interval for the true coefficient of theta I. And this is the formula. Okay, where you reach down and K degree of freedom and your critical T. After that, you substitute all the values in the formula and you will get, okay, the 95% confidence interval. And remember that this is the true coefficient. Sometimes students, okay, are very creative. Okay, instead I show this this kind of answer in class, but they are so creative in changing. Maybe they have the blood of Einstein. They change. Okay, if you do in your final exam, whereby you cannot refer to any materials or sources or books, okay, I do understand that maybe you are under pressure. But when you do the assignment, okay, final assessment, okay, based on online learning process, okay, it is difficult for me, okay, to accept, okay, this reality, okay, because if you think that 0.1769 is greater than beta I is less than 0.1769, okay, let's say I choose the number 0.01, okay, then beta I is greater than 2 point, is greater than 2.3989. So this is cannot be accepted. Okay. In reality, how come 0.01 is greater than 2 point something? So don't be over creative. Okay, up to a point that we tend to be irrational. And please copy all the notes, okay, as I did in the lecture. Unless you are the type who tend to love to read books, you can come up with your own notes. Okay, with a good representation, that's no problem. Okay, you can react like a jury, okay, American Idol. You can sit down and listen. Okay, any question before we proceed to F-test? Okay, now F test. You can refer to page 160. Here's section 5.6. Okay, I give you 10 minutes to read. Okay, page 160 up to 160. Okay, I'll get back at 10:10. Okay, 10 minutes from now.
Character.
you